Hello everyone, I welcome you all for SPK tutorials. Those who are not subscribed to my YouTube channel, do subscribe to my YouTube channel immediately. In this video, you are going to get the complete solution of model question paper for mathematics for CSE stream with the subject code BCS301. So here is what we have: model question paper 1 along with model question paper 2. I am going to consider module 1. I am giving a complete solution of module 1 in one shot for both the model question paper. If you come to module 1, we have a problem on discrete random variable. We need to find the value of k, and we need to find the discrete probability distributions for the question number 2. So that is what sub question we have here. So we need to evaluate a probability of x less than 6, x lying between 0 and 5, and x greater than or equal to 6. So moving on to the solution part, here you have solution. So since we need to find the random variable of the given probability distribution, we need to find the value of k here. So for that you can make use of handbook. So in handbook we have a formula. This is what the formula, page number 17, you have this formula. You can make a note of it. So to find the value of k, you make use of this summation I equal to 1 to n p of xi is equal to 1. Use this formula to find k. Make use of that formula. See here, summation of p of xi is equal to 1. So add all the values whatever we have here. Add all the values what we have here, p of x. So adding all those values, we are going to get here. So an quadratic equation. We are going to get an quadratic equation. Using your calculator, solve this in your calculator. Take out your calculator and solve that equation. Go to equation mode. So in that mode, take an equation 5. In that quadratic equation, ax square plus bx plus c equal to 0. Take that 3. So type the coefficient of k square, that is 10. We have 10. Then coefficient of k is 9, and constant value is -1 equal to. Then press equal to. You are going to get the solution as one value as 1 by 10, another root as -1. So we got two roots, that is -1 and 1 by 10. So as the value k should be always positive here, k should be always greater than 0. So we are considering 0.1 as the k value, k equal to 1 by 10. So resubstituting that k value in the given table, so we get this tabulation. So then we can find out the discrete probability distribution, whatever we have, the sub question 2, that is probability of x less than 6 we need to find. So as the value 6 is less than 6 is nearest to xn, so we will go with the formula 1 minus probability of x greater than or equal to 6. Make use of probability axioms. So 1 minus p of x greater than or equal to 6. So for that reason, 1 minus p of x equal to 6 plus p of x equal to 7, if we find out, it is enough. For probability of x equal to 6, we have the value 2 by 100, and probability of x equal to 7, we have the value 17 by 100. Add those two values, we will get 19 by 100. Subtract this value with 1, so we are going to get 81 by 100 is the required probability for x less than 6. Then we need to find out probability of 0 less than x less than 5. So for that reason, we need to have the value. This is what the range for x, that is 0 and 1. So 0 and 0 and 5. 0 and 5 has been excluded. Apart from 0 and 5, you need to find the values of 1, 2, 3, 4. So probabilities of 1, 2, 3, 4. Summation of probabilities of 1, 2, 3, 4 will be of the answer 4 by 5. So this is what the way of finding the discrete probability distribution. So similarly, going with the last value, probability of x greater than or equal to 6 is given by, as the value x 6 is nearest to xn, so we can directly find out x equal to 6 and plus x equal to 7. So we are going to get 2 by 100 plus 17 by 100, which will be equal to 19 by 100 is the required answer. So Moving on to the question number 2, find the mean and variance of cosine distribution. So this have been explained in the previous video. You can go through that video. You can refer that video. That is video has been given in my YouTube channel. You can go to my YouTube channel. Here you have my YouTube channel. In that I have derived this derive and obtain mean and standard deviation of binomial distribution, and also mean and standard deviation of cosine distribution. Both I have done. You can refer this video, and if you have any doubts you can ask me. So moving with the next question, that is question number 1c. So in the question number 1c we have, in a certain term the duration of a shower is exponentially distributed. Exponential distribution they have given with mean value as 5 minutes. What is the probability that a shower will last for 10 minutes or more, less than 10 minutes, between 10 and 12 minutes we need to find. So going on to the solution, they have given mu equal to 5, represent that value mu equal to 5. So we know that mu is equal to 1 by lambda. So therefore lambda is given by 1 by mu. So I will get the value of lambda as what? 1 by 5. So the lambda value is 1 by 5. Substitute that value in the formula. We know that the function f of x for the exponential function is has been defined as lambda times of e power minus lambda x for x is positive. For x is positive, so we have this formula. So make use of that. So I have made that here lambda value is 1 by 5. I have just substituted 1 by 5 e power minus lambda value is 1 by 5 times of x, it will be minus x by 5, as x ranges between 0 to infinity. So therefore otherwise it is 0, elsewhere it is 0. Using that formula, so we need to find out here they have been given the continuous distribution, that is probability of x greater than or equal to 10 hours. So therefore it shows that it always move from 10 to infinity. So up to 10 to infinity. So we need to find out integral 10 to infinity 1 by 5 times of e power minus x by 5 dx. So we know the integral of e power ax dx, which is given by e power ax divided by a. Here the value of a is minus 1 by 5. That is what the constant value. So that's why we are going to get 1 by 5 times of e power minus x by 5 divided by minus 1 by 5. So here 5 get cancelled. You will be left out with minus of e power minus x by 5. Limits x ranges from 10 to infinity. So substituting the limit e power minus infinity minus e power minus 10 by 5, here you are going to left out with, here e power minus infinity is always 0, minus into minus will be plus, e power minus 10 by 5 will be 2 e power minus 2. Calculating with your calculator, e power minus 2 will be 0.13534 is the value for probability of x greater than or equal to 10. Going with the next value, to find out probability of x less than 10, we need to find out probability of, so as we know that the function f of x has been defined only in the interval 0 to infinity. So they are asking for x less than 10. The function can be written as integral 0 to 10 1 by 5 times of e power minus x by 5 dx. As we know that integration, as I did in the previous problem, in the same manner it will be e power minus x by 5 divided by minus 1 by 5. 5 get cancelled. Substitute the limits. You are going to get minus of e power minus 10 by 5 minus e power 0. Minus e power 0 value is 1. So minus into minus plus 1 minus into plus is minus e power minus 2. Simplifying this using calculator, we are going to get 0.86466. This is what the value for probability of x less than 10. So similarly, to find the value probability of 10 less than x less than 12, as it is continuous function, so the given function here ranges between 0 to infinity. We need to find only between 10 to 12. So we need to consider both end intervals, integral 10 to 12 1 by 5 times of e power minus x by 5 dx follows with the same integration. So we are going to, after substitution with the limits, we are going to get the value as what? 0.04462. This is how we need to solve the problem of exponential distribution. Moving on to the next question. So that is question number 2b. Out of 800 families with 5 children each, how many would you expect to have? 3 boys, at least 1 boy, at most 2 boys, assuming equal probabilities for boys and girls. So this problem is of the form binomial distribution. How we can decide that whether it is binomial? If n is very large and p value is very small, and then we can decide that it is a cosine distribution. But in this case, p value is 0.5 and n value is 5 here. So therefore, I think it is 5 children. So n equal to 5. So we are going with binomial distribution. So let x denote the number of boys in the family. So P represents what? Probability of having a boy, and Q represents probability of having a girl. So the chance factor of getting a boy or a girl is 0.5. So therefore P is given by 0.5 and Q is given by 1 minus P. So which will be equal to 0.5 and N is given by 5. So using the binomial distribution formula, P of x is given by NCx P power x Q power n minus x. Substitute all the value n, p, q. Substituting that, since bases are same here, a power x into a power 5 minus x we have. So bases are same, add the powers, a power x plus 5 minus x, x get cancelled, which will be equal to a power 5. The value of e is 0.5 here. So 5cx 0.5 whole power 5 will be p of x here. But they are asking for to find out of 800 families, we are going to have 5 boys or 5 girls like that. So we need to multiply p of x by 800. So for that reason, I can write that as n into p of x. I will find out the probability of n into p of x. So n value is 800 here. So 5c3.5 whole power 5. So as I need to find out probability of 3 boys, as I am considering x equal to boys. So 5c3 x will be equal to 3.5 whole power 5 into 800. So if we calculate, we are going to get 250 as the required answer. So then I need to find out probability of having at least. So for at least, we need to make use of the formula probability of x greater than or equal to 1. X greater than or equal to. That is the formula for at least. So using that formula, at least 1 boy. So which will be equal to 1 minus probability of x less than 1. Instead of finding up to 5 boys. So directly I can find out, since this 1 is nearest to x naught, I can make use of the axiom 1 minus p of x less than 1. So for that reason, we can find out probability of just 0. 1 minus p of 0. So just put x equal to 0. So we are going to get 5c0 into 0.5 whole power 5. Simplifying that, we are going to get 0.9688. Multiply this value by 800. So we are going to get the answer as 775. So moving with the next question. So probability of having at most, for at most the formula has been used, less than or equal to 2 boys. At most 2 boys, less than or equal to 2. So we will find out x is equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So as 0.5 whole power 5 is constant for each probabilities, for that reason I have taken outside. Then just I have find out 5c0 by putting x equal to 0 plus 5c1 by putting x equal to 1 plus 5c2 by putting x equal to 2. Simplifying this, I am going to get 0.5. Multiply this value 0.5 with 800. I am going to get the value as 400. Is the way of solving the question number 2b. Moving on to question number 2c. So this is what the question number 2c. in a normal distribution, so the problem is on normal distribution. 31% of the items are under 45 and 8% are over 64. Find the mean and variance of the distribution. 31% of items are under 45 and 8% are over 64. Using this values, we are required to find out mean and variance of the given distribution. So probability of x less than 45 is given by 0.31, 31 by 100 is 0.31, x greater than over 64 is 8%, 8 by 100 is 0.08. So we know that a normal variant, a normal distribution is given by z equal to x minus mu by sigma. So put x value here. So that is 45 minus mu by sigma, and that is what z1. I will represent that by z1. Similarly, I will represent z2 as what? 64 minus mu by sigma. Then we require to find out what? Probability of z less than z1. Probability of z less than z1 is given by the formula. You need to know the normal distribution curve. So probability of z less than z1, as we have positive values z less than z1, we need to have the area of this part. So for that reason, this region is what? 0.5, and this region is what? This about z equal to 0. This region is just phi of z1, area of z1. So 0.5 plus phi of z1 is equal to 0.31. So phi of z1 will be equal to, if I shift this term to right hand side, we are going to get minus 1.19. So I need to find out the value of 0.19. So you can make use of the normal distribution table in your handbook. Go to your handbook. There you can take out the normal distribution table. You can fetch with the normal distribution table here. Yeah, coming to the normal distribution table, see here 0.195 is given as z of 0.5. You can note down that value as 0.5. So therefore, this is what I have written. Phi of 0.5 is equal to 0.19. So whether they may give this value in your question paper, if they don't mention that in your question paper, you require to find out using the normal distribution table. This is how we can calculate using normal distribution table. So after coming to know that 0.19 is given by phi of 0.5, I have substituted that value here. So therefore z1 value, this can be also written as it is symmetric about z equal to 0. I can write this as minus 0.5. So therefore equating z1 value on each side, I am going to get z1 is equal to what? Minus 0.5. Similarly, in the same manner, I will find out z2. I will solve for z2. So as we have know that probability of z is greater than or equal to z2 here, as over 64. I have substituted that value 64 here. So it is given by z greater than z2 is given by the formula according to normal distribution. Is greater than this area is given. So out of 0.5, this value is 0.5 minus this, subtract this region. So that is phi of z2. So therefore 0.5 minus phi of z2 is equal to 0.08. So simplifying this, we are going to get phi of z2 is equal to 0.5 minus 0.08. We are going to get 0.42 as the answer. Now I need to find out using normal distribution table 0.42, where that value 0.42 will come. You need to search for it. So 0.3, so 0.492. So this is what 0.42 I can consider. The value is what? 1.4. So therefore 1.4 is phi of 1.4 is what? 0.42. So that is what I have substituted here. Phi of 1.4 is equal to 0.42. Substituting that value, phi of z2 will be equal to phi of 1.4. Equating on both the sides, z2 will be equal to 1.4. Now substituting these two z1 and z2 value in the above formula, in the equation 1, we can fetch with the value mu and sigma. So substituting that z1 value and z2 value, solve this, just cross multiply this sigma values to the left hand side. So then simplify this, we are going to get simultaneous equation. Put this simultaneous equation in your calculator and you can get the value of mu and sigma. This is how we can calculate the value of mu and sigma using the normal distribution value or normal distribution problem. So moving on to the model question paper 1. So we'll see the solution of model question paper 1 now. Coming to the model question paper 1 solution. So in model question paper 1, this is the question they have been asked. They have been asked a shipment of 8 similar microcomputers to a retail outlets contains 3 that are defective. If a school makes a random purchase of 2 of these computers, find the probability distribution for the number of defectives. Find the mean and variance of this distribution. So they have been asked the problems on discrete probability distribution. We'll solve this problem by using discrete probability distribution, and also we need to have the concept of conditional probability distribution. So coming to the solution, so first we need to define what is X. Let X represents the number of defective computers purchased by the school. So we need to know how many computers are purchasing by the school. If a school makes a random purchase of 2 of these computers, so there are a shipment are selling a computer 8 microcomputers to an outlet. Out of 8, 3 may be defective, 3 will be an defective. So we may have the chance factor of getting all the defective computers. For that reason, X has been taken the value 0, 1, 2. So for 0 defective, what is the probability? How to find out? By using conditional probability. So as they are purchasing 3 defective computers, so if there are 3 defective, out of 3 defective, 0 defective, 3C, that's why we have taken 3C0, 0 defective, 3C0 out of 3 defective, 0 defective. So as we have 8 computers from the retailer, so minus 3 will be equal to 5. So remaining 5 computers are good computers. So 5C, 2 will be an good computers. All divided by total computers out of good computers, 8C2. So simplifying this part, we are going to get 15 by 14. Similarly, for probability of 1 defective, so out of 3 defective, 1 defective, 3C1 into 5C1. One good computer may get the school. So all divided by 8C2. After solving that, we are going to get 15 by 28. So if we have 2 defective, so it will be 3C2. Out of 3 defective, 2 defective will be there. So school will not be getting good computers. That's why it is 5C0 all divided by 8C2, which will be equal to 3 by 28. So this is what the probabilities we got. So now putting a table for probability distribution, we get X and P of X. So X has taking place the value 0. When it is 0, probability will be 5 by 14. When it is 1, the probability will be 15 by 28. When it is 2, the probability will be 3 by 28. So solving this, mean will be equal to what? We require to find out mean and variance. We know the mean is given by xi into p of xi. So 0 into, just multiply and take the sum of these two, 0 into 15 by 5 by 14 plus 1 into 15 by 28 plus 2 into 3 by 28. So having simplification, we are going to get 3 by 14. So variance is given by the formula summation I equal to 1 to n xi square into p of xi minus mu square. So here x value is 0, 0 square into p of xi is 5 by 14, that is p of x1. So plus 1 square into 15 by 28 plus similarly 2 square into 3 by 28 minus mu values 3 by 4 the whole square. Simplifying that part, we are going to get 45 by 112 is the required variance value. So this is how we can solve the problem. Moving on to question number 1b. In a factory producing blades, the probability of any blade being defective is 0.002. If the blades are supplied in packets of 10 10 packets. Using cosine distribution, determine the number of packets containing no defective, 1 defective and 2 defective blades respectively in a consignment of 10,000 packets. So just in the previous model question paper, I told you how to decide whether it is cosine or binomial. If they don't mention here cosine also, you need to know that it is a cosine, since the probability of success is 0.002, which is very less value, and n value is large here. So therefore we can go with the cosine distribution. Don't go with the binomial distribution. Okay, so taking the problem here, let x represents the number of defective blades in a packet. So therefore probability of success will be 0.002. N is given by 10 and capital N is 10,000 of packets. So by cosine distribution, the cosine distribution is given by the formula P of x is equal to e power minus mu into mu power x divided by x factorial. Substituting the mu value, how to find out the mu value? So we know the value of mu is given by number of products is multiplied by the probability of success. Therefore 10 we have n equal to 10. So 10 into 0.002, which will be equal to mu equal to 0.02. So we got the mean of that population. So therefore substituting that in P of x, we get e power minus 0.02 into 0.02 whole power x divided by x factorial. Finding out the number of packets containing defective blades in a consignment of 10,000 packets is given by this P of x is multiplied by n into P of x. So therefore n value is 10,000. So multiply that value with 10,000. Simplifying that, we are going to get some value. You can multiply these two things and you can keep ready with simplification by putting x equal to some values. So by putting no defective, first going with no defective, 0 defective, put x equal to 0. So by substituting x equal to 0, we get the value as approximately 9,802. By putting x equal to 1, we get the value as approximately 996. By putting x equal to 2, we are going to get approximately the value of defective is 2. This is how to solve the problem of cosine distribution. Moving on to question number 1c. If the mileage in terms of thousands of miles of a certain radial tire is a random variable with exponential distribution. So we came to know that the problem is on exponential distribution. They have provided the mean value 40,000 miles. Determine the probability that the tire will last at least 20,000 km, at most 30,000 km. So the given problem is of in terms of miles. So let x represents the miles in terms of 1000 regarding mileage of a certain radial tire. So therefore mu is given by 40,000. So by 1000, which will be equal to 40. So mu equal to 1 by lambda according to exponential distribution. So lambda will be equal to mu. So therefore lambda we got as 1 by 40. Substituting, as I told you in the model question paper 1, I have discussed in the previous model question paper, lambda times of e power minus x lambda. Substituting the value of lambda, we get the value of function of f of x as 1 by 40 e power minus x by 40. X ranges as 0 to infinity. So therefore, or if you are directly solving in terms of miles itself, you can solve like that. So go with 1 by 40,000 into e power minus x by 40,000 ranges. If you consider x as greater than 20,000, as the given problem is what, 20,000 kilometer. So I have taken like that, x greater than or equal to 20,000, which will be equal to what, x greater than or equal to 20. X greater than or equal to 20, limit 20 to infinity. Substituting all those values and simplifying, as I have told you how to integrate this. So simplifying that part, we are going to get the solution as 0.60653. Similarly, less than 30. So for less than 30, you need to consider 0 to 30, 0 to 30 range. So if it is greater than 30, it is 30 to infinity. Here less than 30 we have. So for that reason, integral 0 to 30, substitute the function f of x and integrate that part. So substitute the value. So once we substitute the limits, we are going to get the answer as 0.52576. Moving on to question number 2a. So the density function, they have defined that it is a PDF already of a random variable x is given by f of x equal to k times of root x ranges 0 to 1, elsewhere it is 0. Find the value of k, find the CDF of f of x is to evaluate p of 0.3 x less than 0.6. Since f of x is PDF, consider integral limit minus infinity to plus infinity f of x dx is equal to 1. Therefore, as I need to find out the k value here, so the value has been defined only in the range 0 to 1. Only in the range 0 to 1. So apart from minus infinity to plus infinity, the function is defined only in the range 0 to 1. So 0 to 1, k times of root x dx. So therefore, integrating this x root x can be written as x power 1 by 2. Integral of x power 1 by 2 dx will be equal to x power 1 by 2 plus 1 divided by 1 by 2 plus 1. So it will be equal to, after simplifying, it will be, the k value will be equal to 3 by 2. After simplification, the k value will be equal to what? 3 by 2. So once we got the value of k value, substitute that k value in the function f of x. We are going to get this as f of x. Now find out the CDF. So we need to find out f of x is equal to integral 0 minus infinity to x f of x dx. So how to find out CDF means, this is how we need to find out CDF. Keep in your mind, while finding CDF, we need to consider the limit minus infinity to x f of x dx itself. So out of that range, the value of x has been defined only from 0 to 1. So we can consider only 0 to x, only for positive values we'll consider. So substituting that in that range 0 to x f of x dx. So f of x has been defined as 3 by 2 root x dx. So integrating root x, we are going to get x power 3 by 2 divided by 3 by 2. Here 3 by 2, 3 by 2 get cancelled. We are left out with x power 3 by 2. Substitute the limits. So upper limit x is x itself, x power 3 by 2 minus 0. So simplifying that, we are going to get capital F of x as x power 3 by 2. This is what CDF. Solving the remaining probability distribution. So that is P of 0.3 less than x less than 0.6 is given by f of 0.6 minus f of 0.3. The range, we know that the given problem will lies between 0.3 to 0.6. Just if we subtract the function as what, f of 0.6 minus f of 0.3 is enough, as we have already calculated CDF here. So therefore, substituting x value there 0.6 and 0.3, we are going to get the solution as 0.3004 is the required solution. Moving on to the next problem. Find the mean and variance of binomial distribution. Already I have been discussed this binomial distribution in my previous video. You can refer my previous video here. So I have clearly explained how to find out mean and variance of binomial or cosine distribution. You can refer, and if you have any doubts, you can put a comment. And also, if you want more videos, going to my YouTube channel, just type here probability distribution. If you just type probability, here you have plenty of videos on probability. So it is all of model question paper, solved model question paper. You can refer all these model question paper, whether it is 18 mat 41 or 21 mat CS 41. You can refer this. So this also helps you for referring this question papers for your upcoming examination. If you have any doubts, you can put a comment and share this video with your friends. I thank you all for watching this video.